Let's look at lazy loading. Now, lazy loading defines expensive operation. It is one of the most important system-wide performance optimizations in Swift. So usually we have something like this. We have the lazy keyword and then some variable. The variable has to be mutable. And then we have the type. And so this is lazy closure. So we have a closure expression here, and then we're returning the type, and then we're passing some label and then the value here. So let's go back to Xcode. Now in Xcode, we have this class data analyzer, and then we have this property here, data, which is an array comprising of elements of type double, and then we're passing this data inside our constructor method. Now there is a lazy property here, statistics. This property is a dictionary, but then the value is being calculated by this closure expression, which is immediately invoked this by this parenthesis. So the value of a dictionary is returned here. Now you see this lazy keyword. We're going to get back to this in a minute. So here we are creating an object down here, creating an object, and then we're passing the value of our data array using Swift array constructor. So we're repeating for 42.0. This is the value we want to pass, and then we have count of 1 million. So which means in our data array, we're going to be having 1,042 values. Now, this lazy keyword, what it does is, well, if you look at the body of our closure expression, you discover that we have some expensive operations going on. We have this dot reduce, we have min, we have max, on and like that. So with this lazy keyword, what it happens is this immediately invoked closure expression, its execution is delayed at the point of creating this class. This execution is delayed. So we have to like explicitly instruct it to execute once, and then once it executes, that is when we read this property statistics, we are telling Swift to now, okay, execute this immediately invoked closure expression. And then all the loops are going to run. The value return is going to be cached in memory so that we only print that price once, or we incurring that overhead once. And then maybe subsequently, if we now require to read these statistics property, we can just obtain it from memory. We don't have to, it doesn't have, Swift is not going to recalculate everything again. Okay, now when we look at our array data, we have 1 million items. And a couple of expensive operations going on here. We have dot reduce. For this dot reduce to run, this is going to loop 1 million times, and then Swift is going to get the sum, calculate the sum. When we come here for the min, is also going to loop 1 million times. For max value, also going to loop 1 million times. So essentially, we are looping 3 million times for 1 million items. I don't think this is quite optimized for the pattern we are hoping to implement. So which means we could improve upon the code that we have here. So instead of running 3 million loops, well, since we're going to be, so what I'm trying to say is, look at it, if we do print, and then here we do analyzer dot statistics. So we want to get for just average. So we get average for the 2.0. For us to get this average, 3 million loops have run here. I think that's like unnecessary spike for our CPU. It's not quite memory efficient. Okay, so I think I'm getting a warning here. That's because uh, when we do lookup in our dictionary, we get an optional value. So I have to unwrap this. So this is going to give us an actual value. So that's that. Now, since we know we're going to be uh, requesting for each of the values in our dictionary, and then we don't want to run 3 million loops. What if we make each of these properties, each of these values, a lazy property in our class or data analyzer class, so that we can do something like this? You can just delete this and then say we say lazy. So which means each of the value becomes a lazy property. So we can do sum and then gonna double here, and then we can set this to its own closure expression, which is going to do the calculation for us. And then here we can do print calculating sum min max. So we don't have to do the 3 million loops with this approach. So down here, which means we can just do some like down here we can do, since we've created these objects, we can do print, and then here we can just do analyzer dot sum, like so. So that's our sum. So this approach, we only ask for what we wish to calculate. So I think this saves us more time, more CPU resources. Now, there's even a better approach to optimizing what we're trying to do here. What if we, since we know we're going to be requiring all of the properties, that is all of these calculations, these statistics, what if we did a single pass optimization where we compute everything in one loop? So in that case, we keep our dictionary structure, but then we reduce the workload from 3 million iterations down to a single loop of 1 million iterations, and all of our values are returned. We can do that. So let's look at how we might implement that. I don't want this to complain, so I'm going to delete this. And then all of these properties, I'm going to delete them. Let's go up. What else do we have there? I'm going to delete this. And then we're going to delete this. And then we're going to bring our lazy var statistics back. Statistics, which is a dictionary. So string double. And then just as before, we're going to set this to a closure expression. So now we're going to do print. Let's print here. What do we want to do here? Let's call this calculating. Okay, guys. Now we have a re-implementation of our statistics calculation. So this is using a single pass optimization. So this computes everything in one loop. So for all of the values, it's just 1 million loop. So this approach eventually it keeps our dictionary structure and then the workload from like 3 million iterations down to a single loop of 1 million iterations. And I think this is far more optimized than what we've been doing so far. So let me just run through what we have here. We're guiding like as before. We initializing some current mean max like this, and then we are looping through our data, and then in here we're setting our statistic, current sum, current mean, current max, and then eventually we're returning our dictionary here. So which means down here we only need to do print analyzer dot statistics. That's all. And then we get everything. One tick. This is far more optimized than anything we've done today. So guys, that's all for this video. I hope to see you soon.